Hello, ladies and gentlemen of Algebra 2. You're looking at 8-7, and you are looking at closing in on the end of the unit. So today is going to be all about rational stuff, and you're going to see a lot of radicals, and you need to be able to simplify anything and everything into radical form. So there's a lot of rules to remember, a lot of subtleties that you need to pay attention to. So let's kind of get right into it. So how do you simplify b raised to the 1/2 raised to the second power? Well, anytime you have a power raised to a power, you are going to multiply those powers. Okay, so when I do that, 1/2 times 2 equals b to the first. All right, that's kind of the rule here. So any positive number b, and for any positive integer n, here's kind of what happens. N becomes my root b to the first. So n is my radical, basically, my root. This b is my base, and 1 is your exponent. So if I look at 8 to the 1/3, that is telling me that it is the third root of 8, which is just going to be 2. So that's all I'm looking at right now, is the bottom number is my root, the top number is my power, and then I have my base. So if I write this in radical form, this is going to tell me that it would technically be the fourth root of a to the 1, or we just write fourth root of a. For here, this is just going to be the fifth root of x to the first, or just the fifth root of x. That's all I'm doing. Bottom number is my root. So if I kind of go backwards, write this in exponential form, this is like saying y to the first, looking for the third root, y to the 1/3. If I look at this one, negative exponent means this. So if I'm looking at the top, so this would be the fourth root of 16 to the negative 1. Okay, so negative means that I put it in the denominator. So that means I'm going to have the fourth root of 1 over the fourth root of 16. Fourth root of 1 is always 1. Fourth root of 16 is going to be 2. So after all that noise, my answer is going to be 1/2. All right, but notice, don't forget what the negative exponent means. It means you have to flip it over. So if I look at 8 to the 1/3, remember that's going to be the third root of 8 to the first power, or the third root of 8, often called 2. So if I look at this one, this means that this is going to be 3 times 8 squared, better known as the third root of 64. So the third root of 64 is going to be 4, because 64 is 4 to the third power. So there's my answer right there. Boom. So for any real number b and any integers m and n, n's bigger than 1, basically it is the nth root of b to the m. That's what I'm looking for, the nth root of b to the m. Okay, so I don't know why this is over here. If you can remember this, that's kind of what you're dealing with. 3 is your power, 4 is your index, t is your base. So if I look at this one, I am looking for the fifth root of 243 raised to the third power. So top is your power, 4 is your root that you're looking for. So 243 raised to the third power is a ridiculously large number. And if you remember before, I've said, if you just put this into your calculator and raise it to the 1/5 power, then that would kind of give you your answer. So after all that, that is going to be 27. So if I put it in the calculator like this, like if I put this into a calculator, 243 raised to the 3 divided by 5, I would get my answer. But you have to recognize that this is what this represents. Okay, that's what you have to keep straight. So if I kind of write this in exponential form, this would be y raised to the 4 divided by 6. That's all I'm looking at, y raised to the 4 divided by 6. So radius radius of a sphere with a given volume is figured out by that. Find the radius of a ball whose volume is 77. So the radius is equal to 3 times 77 over 4 pi. That whole thing raised to the 1/3 power. Basically, that whole thing is, you're taking the cube root of it. So if I take 3 times 77 divided by 4 pi, I get 18.3824 raised to the 1/3 power. So again, I'm just throwing in my calculator, and I get that radius is going to be 2.64, approximately. Not exactly, but approximately. And all I did was raise it to the 3rd power. So, a couple of things to remember. Rules of exponents. Whenever you multiply, you add exponents. So 2, 3, and 4, that is going to be x to the 9th. Nothing changes here, okay? 1/5 plus 7/5 is going to be 8/5. So my answer is going to be x raised to the 8/5 power. All right, so you got to remember how to add fractions, which isn't too bad. All you got to do is remember bottoms have to match, add the tops. So here I'm going to multiply exponents. I have power to a power, so that is going to be y to the 8th, 2 times 4. This one means I'm going to take everything, raise it to the 1/3 power. So x to the 1/3, if you remember earlier, is 2. This would be x to the 2/3, y to the 1/3. There's my simplified answer. And notice, I'm leaving it in fraction form. That's fine. I can do that. I mean, I can't simplify those anymore, so that's as far as I can go. But I could simplify this, so I did. Anytime you can simplify it. And then when you're dividing, you subtract exponents, so this is going to be nothing more than 1 over m to the 6th. And when I look here, so first off, before I do that, I've got to get the same thing. So 81, this would be 3 to the 4th raised to the 8th over the 6th root of 3. So if I convert that, that's going to be 3 to the 1/2. Well, let me back up. Let me do this first. This is going to be your 3 raised to the 4/8 over 3 to the 1/6. So that would be the equivalent of 3 to the 1/2 over 3 to the 1/6. So when I do this, I have to subtract 1/2 minus 1/6. So that's 3/6 minus 1/6. So after all that, I end up with 3 raised to the 1/3. And all I did was subtract my fractions. So again, remember, match up bottom number and go. So negative exponents, you cannot have them in a final answer. To get rid of the negative exponent, you move it to the inverse side of the fraction and make the exponent positive. All right, so here, this becomes 3 over a to the 5th. All right, so for 15, negative 4 over 5. So this would be like saying the 5th root of r to the negative 4. So this is like saying 1 over the 5th root of 1 over r to the 4th. Now, there are all kinds of problems with this. One, you can't have a root of any kind in the denominator, so I need to multiply both the top and bottom by the bottom. So on the top, I will get square root of 5 over 1 to the r to the 4th. On the bottom, I will get 1 over r to the 4th. And then I have a fraction and a fraction, which I can never have, so I'm going to multiply This is not an easy problem. There's a lot of subtleties to this. So that will cancel. On the top, I will be left with r to the fourth, fifth root, 1 over r to the fourth. There's my answer, that multiplied. A lot of moving parts in that one, a lot of pieces. I would go back and look that one over again. You can never have a couple things in the bottom of the fraction, the denominator. One is a root. Okay, so any kind of square root sign or cube root sign you cannot have. You cannot have a negative exponent in the denominator. And you can also never have a perfect square, so it must be simplified. You can't have a root, a negative exponent, nor a non-simplified answer. So if I look, third root of 16 and third root of x to the fourth. So if I break that apart, 16 is 2 to the fourth. So that means I would have 2 cube root of 2. This would mean I would have x times the third root of x. So when I put this together, I'm going to have 2x third root of 2x. For this one, so let's see, if I have this, that's going to be 2 to the 1/3 over 2 to the 1/4. So I need to subtract those, which I cannot do in its current state, so I need to maneuver some things around. So that becomes 12. So that becomes 4/12 minus 3/12. So this becomes 2 to the 1/12, which is basically saying the 12th root of 2. There's my answer. So simplify. Ooh, look at this big mess. So top, I have to add those two. I'm multiplying them together, so I add them. Well, I get 6 over 3, which is a nice way of saying 2. So I've got x to the second over x to the 1/3. So then I would subtract those. 2 to the 1/3 would be 1 2/3. As an improper fraction, you know, big number multiplied by a bottom number, add top number. So it's going to be 5 over 3. So my final answer would be x times 5 to the third power. So that would be the cube root of x to the fifth. Now, please simplify this. Don't leave it as 5/3. You know, as we talked about fractions, you talked about improper fractions, simplifying those. Same kind of idea. Simplify this. This is going to be x cube root of x squared. There's my answer. All right, take your time with this. There's a lot of subtleties, a lot of little tricks. Make sure you keep everything straight. Come talk to me with questions and do what you can. Use your resources. Last one. So the top one would be y to the third when I multiply that together over y to the half. So if I take 3 minus 1/2, that gives me 2.5. So that's going to be 5 over 2. So that gives me y over 5 to the second. So that gives me y to the fifth square root. So if I break that apart, that's going to be y, and square root of y. So that would be y squared, square root of y. All I did was break it up, y squared, y. So this gives me y, this gives me y, and that's where I got these two. All right, like I said, come talk to me with questions.